and look at what this looks like. So we go through and we talk about finding, and you guys have already did this, so just walk through with me on this one. So period's going to be, again, period for tangent. Since it's tangent, it's going to be pi over b, which is equal to pi over 2. So that means now this period, what used to be pi, now is pi over 2. So we have horizontally compressed this. Okay? The amplitude, though we really don't take the amplitude, and I'll talk about it in just a moment, but we'll just go ahead for now, write this number here, and we'll see why, and it's going to be important in just a second. So the amplitude is going to be 1. Phase shift, none. Vertical shift, none as well. So we're dealing with tangent. And like I say, tangent, one thing you need to get out from it is that tangent, if there's no transformations being done, tangent starts at the origin. So I'm going to put a dot. Is there any phase shift or vertical shift here, guys? Yes or no? No, there's not. So I'm going to go ahead and put a dot right at the origin to start off. And now the idea is, where are my asymptotes? So, well, instead of it being pi, a width of pi, I've got to go out a width of pi over 2. Now, as we just saw this, guys, it's going to go out this way in order to make this happen. Well, if I go out to pi over 2 and put an asymptote, let's say I follow what the measurement is, and I have to do the same thing for the other side because it's symmetric about the y-axis. Is that a width of pi over 2? Is that a width of pi over 2? What is that width there? It's pi. But what does it have to be? It has to be pi over 2. So what I need to do then is I've made this too wide. So I'm going to go in and say, okay, I need to go out pi over 4. What's that width?
Pi over 2.
Now it's pi over 2. So what gets difficult about tangent is you are starting in the middle, and you've got to get your period length. And what I say is this. You take the period that you've calculated, and you divide it by 2. That's how far you go over to the right and the left. You take your period you just calculated, you divide it by 2. So what's pi over 2 divided by 2? What's half of pi over 2? Pi over 4. That's why we went over pi over 4 this way and pi over 4 that way. And so now we have this. So as we talked about, tangent's always going to increase. And so we have this type of deal like, okay, well, another dot needs to happen, guys. Okay, for sine and cosine, we had 5 points. Start, stop, in the middle, and then in the middle of the middles, right? Now what you're looking at here is you're going to have 5 things you have to put down as well. Asymptote, asymptote, in the middle of the middles as well. But now these start and stop is going to be where your asymptotes are, is what it changes, okay? So we've got 2 asymptotes, we've got the middle dot, and then now we got to figure out what happens in the middle of those. So we go through and say, okay, tangent's always increasing, so that means I'm going to have this sort of pattern, and don't draw this, but something like this. However, what needs to happen is I have to go through 2 more dots. I need to put 2 more dots, which means that if that happens, if that's true, there's a dot here and there's a dot there. So, because again, those dots here and here represent the 45 degrees, or the pi over 4. It's when square root of 2 over 2 is equal to square root of 2 over 2. It's where the coordinates are the same. So you always have those 3. So I need 5 things. Asymptote, asymptote, middle dot, and of course those other 2 dots. Okay? And so this follows that pattern there. And I only need you to draw it once. I know on your notes I saw Emma came in and he drew all of them out, repeating over and over again. I only want 1. Period is all I need. Okay? So all you need to see is just 1 there. So we'll go on to the next one. And this is where it's going to start seeing a difference in that amplitude. So the period for this one, again, is we calculate it, since it's tangent, it's pi over b, which is equal to pi over 1, which is equal to pi. The amplitude is going to be the number in front, so it's 3. Phase shift, none. Vertical shift, none. So again, we go through. It is tangent, so we're going to start at the origin unless there's a vertical or phase shift. Is there a vertical or phase shift? No, so then the first dot goes right in the center. So I put a dot right at the origin. And now, like we said before, I need to go left and right the distance of half of one period. Well, our period length is how much, guys? Pi. So what's pi divided by half? Pi over 2. So that means that I go to the right, pi over 2. Tangent's increasing, however, we do have an amplitude. So what is that called whenever we put a number in front of an equation? What transformation is that? Not a shift, but it's vertical something. Stretch. Vertical stretch. So we're going to take this graph that used to look like this. We're going to stretch it. So that means now these dots in between don't go to y equals 1 and negative 1. Now it's going to go to what, you think? So to y equals 3 and negative 3. Not really drawn to scale, but you get the idea. And so you can see that stretch now. So when I go to grade these guys, I'm only looking for your location of your asymptotes, your center dots, and the 2 dots in between. So if you go to draw this and you do this right, that right, but yet you put these on 1, you've only got partial credit for that because you got to make sure you pay attention to what the amplitude is. Now, when we go in and talk about amplitude, let me get to that just real quick. Amplitude, guys, is a distance of how far up this graph goes until it hits its max. That's the definition of amplitude. How far up does the graph go until it hits its max, or how far down does it go to hit its minimum? What do you notice about the top and bottom of these graphs? They're continuously going because there's arrows on the end, right? Which tells us there is no maximum value or no minimum value here. So the question is, what's the amplitude of tangent and cotangent? It does not exist. Does not exist. As a matter of fact, guys, the only trig functions that's going to have an amplitude is going to be sine and cosine, and that's it. In a minute, you're about to see what secant and cosecant look like, and you're going to see why they don't have an amplitude. So with tangent and cotangent, it's going to go off to infinity to the top and bottom, which tells you what is the range. What is the range of a tangent and cotangent function? All real numbers. The range is all real numbers. And you talked about last class the domain, or where the asymptotes are located, and it's a confusing. It's on the table, guys, and don't worry about that. I'm not asking you to memorize that. But the idea is here, and I know on the notes you had a table that you wrote out all the values when you plugged it in and everything, but we are dealing with just something else we can get. Here's another example. Here we go. Cotangent. Perfect. So we look at this one again. Period is going to be pi over b, which is pi over 1 pi. Amplitude is 2. Phase shift, none. Vertical shift, none. Now, cotangent, as I've talked about before a few times, is a little bit easier to graph. You don't have to do the period divided by 2. You don't have to do that nice little gap like you had to do for tangents. The good thing about cotangent is, without any shifts at all whatsoever, you start, which there's not any horizontal shifts here, you start right with an asymptote. And how long till I put another asymptote, guys? Pi. There's the other one. What happens in the center? Pi over 2, it goes 0. As it looked like with tangent. And of course, as I talked about, and this is something you just got to memorize, is cotangent's always decreasing. Tangent is always increasing. So what that means that we have this sort of pattern going on here, but we need to be more specific. And I draw that pattern, guys, to help you out with where the next dot goes. Well, it has to be along this line here, except what y value is it going to be? 2. And over here it will be negative 2 because it has to be decreasing. Next one. Period of pi over b again, which is pi over 1, which is pi. Amplitude, 1. Phase shift. Is there a phase shift here? What is it? Good job, Cameron. And is there a vertical shift? Nope. So, we do have a phase shift here, so we're not going to put a nice asymptote right along the y-axis here, because we have a phase shift, which means we have to move to, just like Cameron said, we got to move to right pi over 2, right? So we go ahead and do that. Move right pi over 2 from the y-axis, and you create your first asymptote to where you start. And how much distance do we need to go along this x-axis to draw our next asymptote?
You know what I meant? From
Yeah.
the origin, you go against.
The shift tells you where to start, and the period tells you how far to go to your next one. So we have that. What happens in the middle is the middle. It's decreasing. And what is the amplitude? Oops, whoops. Yes, sir.
How do you know they're leaving here?
You know it's always decreasing if it's cotangent. One small thing though, be careful, Johnny, and I keep saying this, guys, to help you out. The parent function of cotangent, if there's no transformations, cotangent's always decreasing. We could always introduce a negative sign in front of it, which flips it and makes it increasing. But just know, if there's no transformations being done, no flipping being done, cotangent decreases. I tried to explain that earlier, but I think either it was this or this was not very good in my part. And I think it's more me not explaining to you guys very well about why tangent and cotangent are doing what they're doing. It's all the whole deal of a fraction, and one number's increasing while the other one's decreasing as you're going around the circle, so just look up that. Or just go back and memorize tangent, increase, cotangent, decrease, unless there's a negative in front, and then you flip it over from there. All right? Phase shift just moves off where you start, okay? Vertical shift, okay, so we've not done anything with the vertical shift. Basically, guys, a vertical shift is going to do exactly what it says, which is this midpoint. If that was a +3, you'd have to go up to 3 there. Everything just moves up 3 points. Okay? And so now your starting point ends up being y equals 3. Your bottom point ends up being y equals 2. Your top point ends up being y equals 4. And then you draw your little decreasing thing that you do. Okay? That's it for a vertical shift. Not too hard, as much as there was for sine and cosine. Any clearer?
Yes.
Yes or no? Yes? Good.
I understood it a lot better on Friday, and I don't know what you did differently.
And my execution was probably not as good. One-on-one usually is a lot more effective than 1 on 30. I should have told you to earmuff it. All right, so let's go ahead and look at secant and cosecant on this function. Now, the thing about secant and cosecant is basically you're drawing its inverse function. You're going to go through all the process you did on day 1, guys. You're going to draw its new minimum line, or middle line, its new max line, its new minimum line, its new starting point. You're actually going to draw the graph itself, and then we'll do one last thing to go ahead and finish it off. So what is the inverse of secant? Secant is 1 over 1 over cosine. So I'm going to draw a cosine graph. I'm going to go through the whole entire process drawing a cosine graph, and I'm literally going to draw a cosine graph as well. Okay? So let's go through this. Period of cosine is 2 pi over b, which in this problem is 2 pi over 1/2, which ends up being 4 pi. The amplitude is 1. Phase shift, none. Vertical shift, none. Let's do this, guys. For purposes, I need this to fit in this graph. We have a period of 4 pi. Do you think 4 pi can fit on this graph if we start at the y-axis? No, we can only go halfway. And I want you to see the full entire graph. So, well actually, did you guys mark this one off? It's at the very beginning, isn't it? There's one without transformations at the very beginning. Let's go up there. Sorry, guys. Let's go up there. I forgot y'all have the parent function of these. Sorry. There it is. And since we already got started with secant, let's go ahead and keep going with the secant. So we'll start with the second one. I know some of y'all may have marked through it. I wish y'all wouldn't have, but that's okay. If you can erase it, that'd be great. All right, so again, secant's 1 over cosine. So we're going to do this whole thing like it's a cosine function. So we go through. I'm going to write out period. Well, it's pi. Whoops. 2 pi over b, which is 2 pi over 1. Period's 2 pi. Amplitude is 1. Phase shift, none because it's a parent function. Vertical shift is none again because it's a parent function. All right, so we have a cosine function we're going to graph here. Well, there is no vertical shift, so the middle line for this function goes right through the x-axis. There's an amplitude of 1, so I'm only going to go up 1 to draw its max line. There's a minimum of 1, too, because the amplitude is 1, so there's its min line. There is no phase shifts, so our starting line is the y-axis. Cosine. Does it start at max, middle, or min? Max. Cosine starts at the max, so it starts at the top. Here. And we'll go back up to the top how far? 2 pi. What happens in the middle? Min, good. What happens in between those? Remember, guys, we're looking at that. We're looking at that for a cosine function. Do me a favor, guys, and continue the pattern to the left side. You're not going to have to do this every time, but I just wanted to show you this because it's easier to see if we continue this one more time. So we'll come out here. Negative 2 pi hits its max. Negative pi hits its min. Negative pi over 2 and negative 3 pi over 2 hits a middle. Right, so we've drawn a perfect cosine function with all the transformations that's there. Now this is the parent function, so there's no transformations. If there was any transformations, you would still do that on the cosine function. If it was a vertical shift, phase shift, period shift, whatever's done, you still would go in and do that on this graph. So let's go along. All you have to do now to finish this off is draw vertical asymptotes when it goes through the middle. Every time this graph goes through the middle, you will put a vertical asymptote. every time the graph, this will be true for sine as well, for secant, cosecant, you always will draw the graph like its inverse function, and then you'll put vertical asymptotes when it goes to the center. And one last thing is left, and you'll be done. And now you do what's called flip the graph out, which means you take it from where the max is, and you flip it away. And so you end up seeing this here. So you draw the function just like you do, and you go ahead and take everything out, vertical asymptotes, and then flip them out. Okay, so let's go over here on secant, or cosecant, and see what this looks like. You know what, I'm going to make this a little bit lighter so you can see it a little better. So we go through secant, which is the inverse of what? 1 over. So we go through again, period of 2 pi, amplitude of 1. I know you probably don't have this space because you probably put a table in. Phase shift of none. Vertical shift of none as well. All right. So we go ahead now and we draw our max. Middle is in the middle because there's no vertical shift. Max goes up only 1 because there's an amplitude of 1. Same goes for min because there's an amplitude of 1. Our starting line, well, there is no vertical shift, no phase shift, so it starts at the y-axis. Where does sine start? Middle. It gets back to the middle again after 2 pi. Hits the middle in the very middle of the phase. And of course, as we talked about, as you're drawing sine, it's going to hit its max first, then its min. So you see something like this. We're not going to draw it all the way across. I'll stop right here. You've drawn the sine function with all its transformations. Now you have to just finish it off with 2 steps. Vertical asymptotes and flip it out. So vertical asymptotes every time the graph goes through the middle. And then to finish it off, you flip it out. Now notice, guys, when I hit a max, and I have to say this because it's been done before, if I hit a max, I'm flipping it up. If I hit a min, I'm flipping it down. Okay? So just think of it that way, is if I'm at the top, I got to go up. If I'm at the bottom, I got to go down. I've seen people do this, and that's not right. You'll flip away from the graph. How's that? You'll always flip away from the graph. All right, so there you go. That's what secant and cosecant look like. Again, you're just drawing the sine and cosine function, and then the last 2 steps you add to it is going to be vertical asymptotes and flip out. All right. So let's go ahead and go back to what we did earlier. So we started this off, we ended up with 4 pi. And you know what, we'll just go ahead and stick with 4 pi since you guys have already seen this. Amplitude is going to be 1. Phase shift, none. Vertical shift, none. We are going to deal with the inverse. So what's the inverse of secant? 1 over cosine. Bless you. So we'll go ahead and do this. So we go and say, all right, there's no vertical shift. So Amplitude is 1. We are talking about cosine, so cosine starts with where? Max. Now this is the part. How far until we get the max again? Look up at period. 4 pi, but that's off the scale, isn't it? How far can we get? 2 pi, which is in relation to 4 pi, what? Halfway. So what happens halfway on a cosine function? We know full, we go from max to max. What happens in the middle? Min. Remember, cosine starts at the top, comes down, then goes back up. In the middle of it, you're at the very bottom, the minimum, right? And of course, we know that in the middle of it, you'll have to pass through the center. It'll go from max to min. In the middle, you're going to pass the center every time. All right, so we go ahead now and draw our vertical asymptotes here. There's only going to be one. Well, I guess I could draw the graph, couldn't I? That would help, wouldn't it? Bless you. So, we have our graph drawn, we have our vertical asymptote done, and we just go ahead now and flip out for the max and min. Now, as you notice, they're not full U's or N's because we didn't graph any further than that. We only took the right half of this function and the left half of the other part of it. And so there's your graph of that. Right? So let's look at the next one. Period. 2 pi over b. In this case, it's 2 pi over 1, which is 2 pi. Amplitude's the number in front, so it's 2. Phase shift for this one is it's negative pi or left pi. Vertical shift, none. All right, so let's go ahead and draw our middle, max, and min. So, any vertical shifts? Nope. How far up do I need to go to get my max line? So how far down I need to go as well. There is a phase shift. What was it? Left pi. So actually our new starting line is right there. So secant is the inverse of what function? Cosine. So we're going to do a cosine. As we know, cosine starts with the max. How far until I get to the max again? What's the period? 2 pi, but I'm starting at negative pi. So where on this x-axis am I going to put my new max? At pi. So if I put it here, the distance from here, start and stop, is a distance of 2 pi, which follows exactly what the period is. It's cosine, so what happens in the middle? Min. Got middles in the middles. We have something like that. So we've drawn our cosine function with all the transformations from the graph, from the problem, and now we'll go ahead and draw vertical asymptotes. Again, vertical asymptotes go through the middles. And then you flip them out.
All right, cosecant with another phase shift. So here we go. Period is 2 pi. Amplitude 1. Phase shift of what? Left. Pi over 2. No vertical shift. Oh, great. After doing all that, I'm going to have to make it go away. But you get the idea. All right.
So what is...
All right, so any vertical shifts here, guys? Nope. So we go ahead and draw this. Amplitude of how much? 1, so we go up 1 and down 1. Oh, this is going to be nice and cramped. Is there a phase shift? What is it? Left pi over 2. So my new starting line is right here. What is the inverse function of cosecant? Sine. And sine starts where? How far until it hits the middle again? At 3 pi over 2 is where we need to put the new dot because it's a period. It's a gap of 2 pi. It is sine, so we hit the middle again. And of course, as we talked about, since there's no negative in front, it hits its max first, then it hits its min. And so you end up with something like that. Vertical asymptotes next, right? Through the middles. And then you flip them out. Do one more just for practice again, because this one actually has a vertical shift. It's one of the few ones we've had with a vertical shift. All right. Period is 2 pi over 1/2, which is 4 pi. Amplitude is 1. Phase shift, none. Vertical shift of which direction? Up 1. So now we finally get to draw a middle line that is not on the x-axis. Because we've moved up 1, my new middle line is going to be y equals 1. Amplitude is how much? 1. Is there any phase shift here? Nope. So we start at the y-axis. That was pretty bad. I know, right? I'm feeling it. Pardon? No, you don't have to. As long as you know it, that's great. I just do that just to help you guys out. And then cosecant is the inverse of what function, guys? And sine starts in the middle. Well, we got to go the distance of how far until we go back to the middle again. Or not back to the middle, but how far do we have to go for this whole period to be complete? 4 pi. Does that fit the grid? No, it doesn't. So what are we going to have to do? Go halfway. What's halfway in a sine function? Where does that dot go? It's a 2 pi, but what is the middle? since there's no negative sign in the front of this function, it's going to go to its max. So you basically got is just a big drawn out arch. We've drawn the inverse trig function. Draw your asymptotes at the centers and flip the function out. Any questions about that one? Let's finish off the table. Period of secant and cosecant is what, guys? Two pi for both of them. Amplitude is going to be that A value. Oh, no, wait. Time out. Amplitude. What do you notice about the graphs? Well, look at yours. What do you notice about the graphs of these functions? Do they have a max or minimum value? When you flipped out the functions, what did you put at the end? Arrows, which means what? This continues all the way into that direction. So here's the deal is, there is no amplitude. However, the amplitude is going to tell you what, guys? It helps with the range, yes. It helps with the range. What does that amplitude tell you? For the amplitude won't tell you that. The amplitude always helps you with the range. So let's go back to sine and cosine. What did amplitude tell you about sine and cosine? How far up and down it goes, right? It's max and it's min, correct? What do we notice about the transition from sine, cosine to secant and cosecant? What's the connection between the max and the min, guys? Look back at your graphs. I want you to find one max point on your graphs you've done, and I want you to circle it. Go back to our original trig function. When we did the graph of sine, I want you to circle the maximum value of it. What do you notice about that point in relation to its inverse trig graph? What you end up doing? Is that the point where you flipped it out? It is. So let me tell you what amplitude does. Amplitude is when you're looking at a graph, we'll do it this way. Thank you. When you look at a graph of its function, let's say we're looking at a sine. Here, I told you in the middle you're going to come up with its asymptotes. And then what I had you do was take the max value and flip it out. The min value and flip it out. So what you notice is, as the amplitude starts to get smaller and smaller, I'm bringing the max and min closer and closer together. Or vice versa, I'm stretching apart. So that amplitude tells you how far apart the top of this and the bottom of that is. So if it's an amplitude of 1, that means from the middle here, I went up 1 and down 1. So what's the distance between this point and this point along the y-axis? 2. So I've gone from the middle, the amplitude's 1, so I got down 1 and up 1, which gives you a total distance of 2. If the amplitude is 3, what's going to be the total distance between those points? 6. Exactly. It's the idea of taking a graph and knowing its max and min and transferring it to amplitude, and vice versa. And vice versa. All right? Any questions about that one? All right. So let's go ahead. You've already done, well, you graphed all of these except for number 3, right? Is that correct? Or should have? Yes, no, maybe so. No, you didn't? So you didn't graph any of these? You haven't graphed any of them? All right, let's get busy then. Let's graph some.